What's up, you guys? So I wanted to make this video as a response to my video about the WRX and its reliability, in particular with the Donut Media stuff. But before we get into it, guys, if you wouldn't mind, please go ahead and hit the subscribe button below down here, wherever it is, somewhere over here. And also click the bell for notifications on when new content drops, so that way you are first informed on when a new video is dropped. Also, at the end of this video, if you enjoyed it, please give this video a thumbs up. It really helps the YouTube algorithm so I can reach a much broader audience and share this with your friends, your car friends, running friends, whatever you're here for. Just go ahead and share it with your friends if you enjoy the content that we're going to discuss. So, let's get into it. I am going to concede that there are some issues with Subaru Boxer engines. There are some inherent flaws, some are engineering flaws, some are production flaws, and I wanted to discuss those just a little bit today with you. So there is a production flaw. This is something that's been going on since really about model year 2011, 2012, where the RTV sealant, this is something that has been popping up on my newsfeed a little bit more. Bits of RTV sealant have been breaking off and falling into the oil pan, which has been getting sucked up into the oil pickup tube, clogging the screen at the end of the oil pickup, and causing oil starvation, which leads to rod knock. This has been a problem since right around 2011, 2012, somewhere around there. And I believe that that has to do with the quality control aspect from Subaru. I think there's an issue there. Subaru, since really the late 2010s, has seen an exponential growth. They're one of the few companies that came out of the recession really running hard. The demand for Subaru vehicles just far exceeded what their projections were, and because of that, they tried to keep up with demand in manufacturing vehicles and engines. Because of that, at one point, and I want to say this is about 2015-ish, basically Subaru told Toyota to kick rocks and stop producing their Camrys at their Indiana plant so that they could focus on building more Legacies, Outbacks, Foresters or something, Ascents, and all the other vehicles that are associated with that Indiana plant. So there is, I think what happened is they were trying to produce more of these engines, and because of that, the time that it takes to build these engines and basically build them with quality and make sure that you go through and it's got the right bead or the right amount of sealant that you're putting around the oil pan, I think kind of went on the wayside because they were trying to increase volume, and a lot of times when you increase volume, your quality goes down. So kind of look at it like McDonald's, right? They're high volume, but are you going to get a good quality burger? Not really. So it's kind of the same way with these engines, and unfortunately they kind of went on the bad side, and the downside is it affects Toyota as well, because the GR86 is plagued with the issue on the FA24 engine. So it's not just, you know, Subaru vehicles and just Subaru in general, but it's also affecting Toyota as well. So that is a major issue for Subaru that they need to resolve, and it's been going on, in my opinion, for way too long. They really need to resolve that particular issue, particularly with their high-performance engines. So there are some other inherent issues that we can discuss. One of them is the oil pickup tube. That is another one. It tends to crack right at the top where it mounts to the bottom of the engine. It's a common problem. That is something that should have been resolved. I don't see it too much on newer engines, but it has happened on some of the older engines, the older EJ engines, and that is a common problem. And if it cracks right there where it's welded to the flange, it doesn't cause the proper suction to get oil up to the crankcase and can cause rod knock. So there is some inherent problems there, and those are some that honestly you don't have to be modifying the car, they just happen. And you don't have to drive the car hard. Sometimes they just happen, and that's the unfortunate side of it. And unfortunately, Subaru fights back on this, even though it is their fault. The other one is the ringland failure. It's common. We talk about the ringland failure. What is the cause of ringland failure? Well, you have to look at the design of the piston first. For one, it's a cast material, it's not forged, and that is a bit of an issue, but it's cost-cutting measure, and they also assume that you're not going to be throwing a crap ton of boost at the stock bottom end, and let's face it, we all do. So some of the ringland failure issue actually has to do with the design of the piston itself. The piston rings, the way they are located, or where they are located on the piston itself, the first ring is actually located closer to the top than maybe Subaru would like to have designed it, especially when you're looking at maybe some of the older EJ engines from Japan back in the late 90s, mid to late 90s. And what that has to do with is emissions control, right? So boxer engines tend to produce more hydrocarbons than a typical inline four-cylinder. And those hydrocarbons will build up around the piston. And if you have the piston ring lower, you build up more hydrocarbons, and that produces more emissions. So what you do is you move the ring closer to the top of the piston, even if it is, a half a millimeter or 1 millimeter or whatever, closer to the top of the pistons, you can drastically reduce the amount of hydrocarbons that are emitted out the exhaust. And so in order to reduce the hydrocarbons, they move the rings to the top, closer to the top of the piston, which means that you have less material between the ring and the top of the piston, and that can cause cracking, particularly in high heat situations, and causes ringland failure. So that is a major flaw right there. But it's kind of, their hands were tied with that particular engine and the design, because they had to fit emissions control to reduce the hydrocarbons being output by the vehicle. So that's a problem. But I just mentioned heat. So if you produce a large amount of heat, that can cause ringland failure. Well, so it's not just the piston ring, but it also has to do with the design of the factory exhaust manifold, which is that cylinder 4, which is the common one that fails, is the furthest one away from the O2 sensor that is able to adjust the car's air-to-fuel ratio. And what happens is you have a shorter runner on one side, you have the longer runners on the other side, and when they fire, the exhaust pulses meet up in a particular way that the ECU is constantly compensating for a rich or a lean scenario in each one of the cylinders. So what it'll do is it'll adjust the injector pulse width on each one of the cylinders to try to compensate the air-fuel ratio. And what happens in cylinder 4 is it'll try to lean out, or maybe it adds too much fuel or whatever, and it pre-ignites and causes excessive heat. And especially when you're talking about high boost situations, because let's face it, we don't keep these things stock. So when you're upping the boost from, say, 13.3, which is the STI, or 11.5, which was a WRX at the time, you up that to closer to 20 pounds, you're adding more heat to the engine, which is then going to cause more stress on those parts, more heat, more stress, so on and so forth. So it's a combination of bad flaw design, and then a little bit of it is user error, although it does happen even in stock form, but excessive heat can usually kill cylinder 4. Honestly, the rectification of it is to just put an equal length manifold on it, which even without a tune, you'll notice a night and day difference on how the car drives. It drives smoother, it feels better, it feels healthier, it has a more linear power band. But you're asking, why would Subaru then put an exhaust manifold like that on the car? Well, it has to do with the lag time on the turbocharger. So if they typically on equal lengths, the lag time on a turbocharger is a little bit longer. Where on the unequal lengths, because you have a shorter runner, it's able to get the exhaust gases through the turbocharger, which is a pretty far distance away. It's able to get the exhaust gases through the turbine of the turbocharger a little bit quicker, so it increases response time. And that is one of the primary reasons why they keep the unequal length manifold on it. Now, Subaru did use a twin scroll turbocharger system in Japan, which does use an equal length system from the factory. but we just never got it over here in the United States. But that is one of the common flaws, and if you go equal length, not only does it have equal scavenging from all 4 cylinders, usually the tubes are a little bit bigger, which reduces exhaust gases being held up in the cylinders and can relieve some of the pressure that you see inside each one of the cylinders. So that is also a huge advantage to going with equal length, or really an aftermarket header anyways, but equal length for sure. The final part of that is the cylinder 4 cooling mod. So cylinder 4, unfortunately, the way that the cooling system works is there's not really a good flow of coolant going through cylinder 4 or around cylinder 4. It kind of gets trapped there, and it doesn't really flow very well. So that area will get predominantly hotter than maybe the rest of the cylinders just based on the coolant. There is a port that is located on cylinder 4 for coolant to passage its way out into another line. I don't know why Subaru didn't do that from the factory, but there is a plug that's there, which is why they make the mod, which ties into a coolant line that goes to your heater core right above it, and you just tap into that line, and there you go. There's your cylinder 4 cooling mod, because now it's able to get that coolant out of that cylinder area and allow fresh, cooler coolant to go into that area and keep the cylinder walls cooler. Which will help the cylinder 4 ringland failure problems. So there are some inherent problems. Now the 5-speed transmission is also a huge failure because the way the 5-speed was built was not proper. The 5-speed has a very long input shaft, and the casing of the transmission only has, I want to say it's like 2 mounting points for the gear shaft, the input shaft gears. And what happens is when you start putting a higher load on the transmission, the input shaft will actually flex. It starts to flex a little bit. And even though it's minute, it still flexes. And what happens is when you put that high load, that high stress, high torque, the gear sets start pulling away from each other, right? And when they start pulling away from each other, you're not getting a good contact patch, and then they basically shear from each other. And that's when you get, your second gear, third gear, fourth gear, just shearing itself apart because it's so much stress, so much torque. Now there's, people say, well, blast plates or this, that, or the other thing. It's really, the blast plates are maybe going to help just a very little bit, but it's still not going to be enough to keep that input shaft from essentially bending because of the amount of torque. And so the final part would be, well, what about PPG gears? Well, you can do the PPG gears. They have a little bit deeper cut. They're built a little bit stronger, so those will work. But there's also it's still running on that same factory input shaft, which is known to flex, and it still only has those 2 mounting points. So even then, PPG gears are only rated to about 450 foot-pounds of torque, and eventually they're going to shear apart. I have had a friend shear apart PPG gears because there's just too much load on the transmission when he went from, I think, second into third gear and sheared apart PPG gears. The other thing is the way that it's designed, the way that the synchros are designed, the way that the shifter and the shift linkage is designed is built to be more daily driver friendly. So there's a little bit more slop and a little bit more play in it compared to an STI gearbox. The STI gearbox is definitely more robust, has a lot more mounting points for the gears. The gears are also wider, deeper, stronger. It's just an overall just much better transmission, which I have in my car. So the 5-speed, yes, for sure, that is a flaw. I've actually blown 3 5-speed gears on my old car, on my old WRX. This one I swapped over before I did that because the clutch was actually shot, and I decided, you know what, let's just do a whole drivetrain swap rather than put a new clutch in it, and eventually it's going to break down the road anyways. So I did the 6-speed, much better. It shifts much better. You can definitely tell the difference between the vehicle, the 6-speed and the 5-speed. So those are some inherent flaws. We'll 100% agree with it. There's also some other things that people have brought up. Like, Subaru stereos have always been garbage, 100%. Go aftermarket. Whether it's the radio, the speakers, it doesn't matter. Subaru stereos have always been garbage. So I always tell people to upgrade those. The AC system, I'll be honest with you, just about every Subaru that I have been in, the AC system is kind of okay. When you compare it to like a Ford AC system, which will basically freeze you out, the Subaru AC systems are kind of meh. So yeah, there's just a couple of inherent flaws with Subarus, but and the power steering pumps will constantly leak. If yours doesn't, I'm surprised, because they all do. Every one that I've ever seen, the power steering pump leaks. So yeah, there are some, like I said, some inherent flaws, but a lot of it is just do some maintenance on the car. A lot of failures are due to the driver, the not maintaining and all that kind of stuff, but there are some that I will concede are, yes, it's a flaw that is designed by Subaru, but if you know how to handle it, like the ringland failure, if you know how to handle it, you can prevent it from happening on your car. So, but again, these motors aren't really built to handle 500-600 horsepower, 700 horsepower on stock internals. They're really built to handle about 350, that's pretty much about max, 350 to the wheels, so about 400 on the crank, and that's really about it. That's about all they're going to handle before you start blowing stuff up. So, but can it be reliable? It still can. I have 140,000 miles in that car. Like I said, my friend has his Legacy at over 200,000 miles. My wife's old WRX is now well over 200,000 miles, and they're all stock engines. They've never been touched. They've never been swapped. So they can be reliable. You just have to know what you're doing and just keep your eye out on the things that could fail. So thank you guys for watching. I appreciate it. And as always, enjoy the drive.